This is our dataset that I got from the official Kaggle website. So what is the dataset about basically? There was an accident of Titanic ship and many people died in that accident. So these are the details of their passengers and whether the person survived or not. Okay, there are approximately 10 to 12 columns here. First is passenger ID that represent each passenger uniquely. Then there is survived column where 0 and 1, there are two values. 0 represents the person died in the accident and 1 represents that the person came out alive from the accident. The third column is P class, passenger class. There are basically 3 classes, 1, 2 and 3. Then there is name of the passenger. Then there is gender of passenger, whether it was male or female. Then age of passenger. There are some missing values, as you can see. We'll deal with them. Then there is sibling / spouse, which means whether the person was traveling with his or her sibling or spouse or not. Then there is parent / child. It is same as sibling and spouse, whether he was with a parent or child or not. Okay. Then there is ticket number, fare, the cost of traveling. Then there is cabin. The cabin was only assigned to the people who were in class 1. So all the other classes have null values for the cabin column. Then there is embarked. These represent 3 locations. Okay, so this is the data set is about. Now we'll get the entire overview of the project and the code that we are gonna go through. Table of contents. First thing that we'll see is what is the dataset about. What is the dataset is about? Getting basic insights, handling the null values, performing EDA. EDA stands for Exploratory Data Analysis. Then we'll perform the feature engineering, data pre-processing, and all that stuff. Training the model, performance evaluation, conclusion, and references. Okay. So first of all, what is the dataset is about? The Titanic Survival Prediction is a popular machine learning problem that involves predicting whether a person survived on the Titanic ship survived or not based on various features. Features include information such as name, gender, age, if passenger had any sibling or spouse, whether they were traveling with a parent or children, the number of the ticket, the fare, the cabin, etc. etc. We're going to use logistic regression algorithm. Okay. So as we know, logistic regression is suitable for binary classification problem, and this is a binary classification problem. This is where I got the dataset from. Okay, this is the official Kaggle website. You can get other notebooks for this dataset also here. The first step we'll do is getting basic insights. So first of all, what is the size or volume of the dataset? There are 891 rows, which means we have the data for 891 passengers, and there are 12 columns, 12 features. Okay, features of the dataset, we already seen the features. Now we'll classify the features into categorical, numerical, and other. Categorical features are the features that represent a particular category. For example, passenger class 1 is a category, passenger class 2 is another category. In the gender, male is a category, female is a category. So these 3 are categorical features. Numerical features are the features that have numeric value basically. So age, sibling or spouse, parent, children, fare are all have numeric values and numbers basically. The other features represent a sequence of characters, kind of string. So name, ticket, and cabin. Looking at the data set, we have already done this. Survived is the target variable, okay, that we have to predict. 0, which means the person didn't survive, and 1 survived. The second step we'll perform is handling the null values. So only 3 columns have the null values, which are age, cabin, and embark. We will do this in detail and we'll perform the entire code. We're just getting the overview here. So age has 177 null values, cabin has 687, and embarked has 2 null values, only 2. Right, so there are basically two ways to handle the null values. One is deletion and second is imputation. In the deletion, we will just delete the rows that have any null value. And in the second step, in the imputation, we'll try to fill the null values by either mean, median, or mode, depending on the needs. So here we are performing the step to handle the null values. We'll see this in the code. Then there's EDA, Exploratory Data Analysis, where we can get basic insights and patterns, underlying patterns in the dataset by plotting count plots, pie charts, disk plots, histograms, box plot, heat maps, and many more things. So this is basically a count plot which represents the number of a particular category. For example, 35 people out of 900 did not survive and 365 did survive. This is the plot for the passenger class, that 200 people were traveling in the class 1. These are the number of person traveling in the class 2, such things. Then there is pie chart. Pie chart is similar to count plot, just it is in a circular format. And then this is called disk plot. This is disk plot. We'll see how to read these things. Then there is histogram, box plots. Now these things represent the outliers, and the line, this line, middle line, represents the median of a particular column. Heat maps, we'll see how to read the heat maps, how to find the correlation between a particular two columns, whether the relation is strong or not. 1 represents that the relationship is very strong, and -1 also represents the relationship is very strong. 0 represents that there is no relation between two columns. Then we'll do the feature engineering, which is the most important section. Dimensionality reduction. Dimensionality reduction is the process of reducing the number of irrelevant and redundant features. We'll convert the high dimensional dataset into a lower dimensional dataset. Okay, so for example, we have nothing to do with the name. I mean, we cannot predict whether the person will survive or not based on the name. We cannot predict based on the passenger ID. We cannot predict it from the ticket number. These things just don't matter in the prediction, so we will remove them. Right? Converting the categorical features into numerical features. So basically, logistic regression wants all the features in numeric type, so we are going to convert these features into numeric one by encoding them. Feature scaling. Feature scaling is the pre-processing step that standardizes the range of values in the different features, ensuring that they're in a similar scale. We'll see how this feature scaling works. After performing all kind of pre-processing steps, this is our final dataset. This is the final dataset, which has all the pre-processing done on it. Then we'll train the model using the logistic regression algorithm imported from the sklearn library. First, we'll perform the train test split. We'll test, give 15% of the data for testing and the rest of the data for training. This is our logistic regression algorithm. We'll fit the data into the logistic regression algorithm and predict on the test data. Performance evaluation, we'll use 3 things to evaluate the performance. The first thing is the accuracy score. The second thing is classification report, which contain the precision, recall, F1 score, and all the other things. Then there is our confusion matrix. And that's how our model is finished. Conclusion, right? So this is how our project is gonna look like. And I hope you watch all the videos of this playlist, right? I will provide the link of dataset, the link of this presentation, all the things in the description. Okay, and if you like the video, please do subscribe the channel also. Thank you.